Hello Rama. In today's lecture, we are going to learn how to create periodic lattice structures using rectangular cell maps. Okay, so and that too we are going to generate specifically strut-based periodic lattice structures. So let's start. First, we can give the name of the file as strut-based strut-based rectangular periodic lattices. Okay, and can give the description of as the generation of strut based rectangular periodic lattice structures, and our section name as periodic strut based periodic, like a rectangular periodic lattice structure. Okay, now to create or to design periodic periodic lattice structures, so we need first periodic volume lattice or periodic lattice, and then we need to create the any like a rectangular volume lattice, like rectangular structures, and then we need to fill our respective unit cells. Now in today's lecture we are going to focus on strut based unit cells. So let's start. So let's go to the ribbon of this lattice tab. Then after we can go to the lattices. Here we can find periodic lattice. Okay, so earlier we have learned how to generate the volume lattice structures using rectangular volume lattice and cylindrical volume lattice and spherical volume lattice. In our today's lecture we are going to learn how to create any lattice structures, that too they are specifically periodic lattice. So let's select this. So either we can select from here, or we can directly search here like a periodic lattice. So likewise we can get the periodic lattice or any kind of blocks. So now we are going to delete this. So let's use this. Okay, so here what do we find? So within periodic lattice we need to give three major input parameters. They are geometrical parameters. So they are mainly, first one is unit cells. We need to specify what type of unit cells we are going to use. Suppose in our today's lectures we are going to generate like strut based unit cell. In nTopology, as I said, that there is no specific term of strut based, but there is a term of graph unit cells. I will show you later on. Then we need to specify the cell map. So in which cell map, like map means like either is this rectangular coordinate system, or is this cylindrical coordinate system, or is this spherical coordinate system. So in our today's lecture we are going to focus on rectangular, rectangular means rectangular or Cartesian coordinate system. So we have the large space of the Cartesian coordinate system. So within that we are going to create the particular volume of the lattice. Okay, and we need to specify the respective unit cell one parameter. So let's select the unit cell. Either we can select the unit cell directly from here itself by clicking the double click. Here we can find the unit cell. So in our today's lecture we are going to focus on graph unit cell. As I said that in later on I will show you how to create the surface based TPMS unit cells. So let's only focus on the graph unit cell, and either we can get it from here or can get it from here also. In lattice tab we can go to the like a ribbon of a unit cell tab, and there here also we can found this. So or we can also find it from here also, like suppose graph unit cell. Okay, so this is how we can find it in three ways. So I suggest that if you just click here and just press it here, or just remove this. We can select from here as well, so that it is better for you. So you can make it as a a variable. So let's make it as a variable. Make a right click on it and make it as a variable. So suppose we can give as strut unit cell. Okay, this is our variable now. So let's place this here, and now we can change the, we can give the unit cell type. Suppose in our today's lecture let's select the simple cubic. Later on I will show you how to select the how to give the other unit cell as well. This is the benefit of our nTopology software. So let's select the simple cubic. Now this is our unit cell of simple cubic. What do we observe here? The outer boundary, it is perfectly cubic, and here we can find the UVW like coordinate system. So like a Cartesian coordinate system. And here if you see that this inside it is like it has some radius. outer side it is like completely plain, because we are considering this unit cell domain only, and if somebody wants to increase the thickness, they can increase it by changing this parameter. So we have already changed. So let's, okay, now we have already placed this here. Now if somebody wants to change anything, they can directly change it from here as well. Or if somebody doesn't want to, doesn't want to make it as a variable, then they can freely like mm, they doesn't want to like leave it. Okay, and now, so if somebody wants to give the orientation, they can give the orientation. It's up to you, but for now the orientation doesn't have any that much effect. So it is only for like unsymmetric or any 2D lattice structures. In that case, suppose in plane structures and out of plane structures. So let's go ahead. Now we want to specify the cell maps. So let's find the cell map. Okay, so what do we observe? There are various kind of cell maps. Okay, either we can select it from here, or we can select it, double click here, and we can get it from here as well. As I said, that in three ways we can find it. So my suggestion is to, instead of going here, if you're, either you can select from here, or you can directly go to the lattice tab, and here we have the cell maps, various cell map. Total we have the 6 types of cell maps. In our today's lecture, we are going to use the rectangular cell map. Let's select this. So rectangular cell map. Yeah, what do we observe here? Within the rectangular cell map, cell map, we need to specify the particular volume. As I said, that rectangular cell map means it considers the Cartesian coordinate system. It generates the entire lattice, like entire map, using the Cartesian coordinate system only. So I will show you what exactly it means. Let us minimize this, and yeah, suppose if somebody doesn't want to, what is volume means, as I said, that either you can select the cube or cylinder or sphere or torus or any conical shape or any complex shape, any shape, it is up to you. Suppose, as I said, suppose mouse shape also. If somebody wants to fill anything, volume, it is just a volume, it must have some dimension. Okay, so either somebody can select it from here. If somebody not able to understand what exactly, as I said, that you just simply go to the create, and within the create, we can go to the primitive tab. Here we can have various shapes, 3D shapes. So let's select the cube. Okay, let's select the cube. If somebody wants to, suppose cube, here what do we observe? For cube, we have one parameter, that is 1 point, which is within the middle of the cube, and it has equal sides, like 10 mm, 10 mm, 10 mm. If somebody wants to give the cubic, suppose somebody wants to cubical, then they can give the, suppose they want different length, width, height, so they can simply select the box here, and from box we can, it's same, it has a center point, and it has length, width, height. If somebody wants to vary the length, and they can give the different dimensions, so it's up to you. Let's go ahead with the box and place it within the volume. Okay, we'll place it within the volume. And now let's minimize the box, and now we can give the cell size means what, like unit cell size. Now we have the entire 10 mm, 10 mm, 10 mm cell map. Within the cell 10 mm, 10 mm, 10 mm cell map, we need to give the unit cell size. Suppose we have the 10 mm. If unit cell size means it should be less than the 10 mm only, less than or equal to 10 mm. So in that regard, let's select the cell size as 2 mm, 2 mm, 2 mm. It is up to you. It can be cubic or it can be cubical. If somebody wants to increase the height, then they can give the different dimension. It is up to you. Okay, let's see. This is our cell map. We have the, what do you observe? This is our rectangular cell map. In cylindrical cell map, it has different shape. It uses the Cartesian, like cylindrical coordinate system. In spherical map, it uses the spherical coordinate system. But in today's lecture, we are using rectangular cell map. So here it is generated based on the Cartesian coordinate system. We can clearly see this. Okay, so as I said, that our unit cell size is 2 mm, 2 mm, 2 mm. Okay, how we can observe that? We can, let's see, select this, and let's measure, like let's measure this, how much it is. 2 mm na? Means it has some angle, that's why we are not able to accurately measure, but it is a 2 mm, 2 mm. Total how many we have? Suppose, let's see, total 1 2 3 4 5, it means 5 to 10, 10 mm. Here also 10 mm. So likewise, we have created our rectangular cell map. Now now if somebody wants to create the frame, it is up to you, it is optional. So in today's lecture, we are not going to create it. Let's go ahead. Now let's generate the simple cubic lattice, and place this cell map within the periodic lattice. Okay, now yeah, next, the final parameter, what do we have? Now we need to specify the thickness. Okay, let's specify the thickness as a 0.25 mm. Now wait for some time, the lattice structure is generating. Yeah, this is how our lattice structure is finally generated. Okay, this is our lattice structure. I hope you're able to see this. Yeah, okay, see how beautiful it is. Totally, now we have generated the lattice structure. like a simple cubic lattice structure this is, and we can see it's a symmetric nature along all the axes. And if somebody wants to change the thickness, suppose 0.5 mm, it is a variable now. It is up to you how much it is based on the size of the rectangular cell map. Then based on that you can consider the thickness, how much exactly do you want to use. So this is how one can generate the cellular lattice structure, like a simple cubic lattice structure. If somebody wants to create other unit cell of the strut based, like a body centered cubic or face centered cubic, as I said that here we have the variable, if I change the body centered cubic, then let's see what is going to happen. See how beautiful it is. Lovely. Yeah, have you seen this now? Yes, yes, this is our BCC lattice structure. Like this is our body centered cubic lattice structure. Along the all the axes, we have five unit cells, and it looks perfectly. It has perfectly cross-sectioned cylindrical struts. And again, this is all about the body centered cubic. And if somebody wants to use like a face centered cubic, they can simply use it by changing the unit cell. This is the benefit of our nTopology software. Okay, this is how one can create various lattice structures. See how beautiful it is. Okay, now we have generated various lattice structures. Okay, yeah. Suppose like here we have changed within the start unit cell. Suppose we want to create them, show them again and again. It means we can copy this, and or we can simply duplicate this, and here we can write the rename it as uh, actually it is loading. Yes, that's why. Mm, like okay, either we can make the variable. So this is FCC, and this is also variable. This is simple cubic, and we can again duplicate this, and this has BCC. Okay, and let's remove this. Even we can delete this also. Now what I'm trying to say, let's just wait for a few minutes. Graph unit cell, simply place it here. Yeah, place it and give the simple cubic, and again select the graph unit cell and place it here, and change the body center cubic. Again select the initial and give the face center cubic. This is how one can generate the hybrid lattice structures also, isn't it? Yeah. Okay, that's it for today. Let me delete all these things. What do we learn here today? We have learned how to create the periodic, like strut-based periodic rectangular lattices. So initially we have selected the periodic lattice from the lattice tab, and later on we have given its respective geometrical parameters such as unit cell, strut-based graph unit cell, and later on we have selected the rectangular cell map, and we have given the thickness as a 0.5. So that's it for today. I hope you understood. So thank you.